Okay, so we're going to start 3.1, and the first thing we're going to do is list what we're going to cover in this section. So by the time we're finished with 3.1, and this will be split into 3 videos, you should be able to calculate slopes, identify parallel and perpendicular slopes, as well as identify angle pairs formed by transversals. So the first thing we're going to look at is slope, and this should be pretty familiar for those of you who have finished Algebra 1. Slope is the difference of the y-coordinates divided by the difference of the x-coordinates, sometimes called rise over run. So you use a lowercase m equals y2 minus y1 divided by x2 minus x1. This is also equivalent to y1 minus y2 divided by x1 minus x2. The thing to keep in mind is that you, starting with the point designated 2, you match up the x and y's on that. Okay? So let's calculate the slopes for the following points. This one has already been done for you. They took the difference. I'm going to label this x1, y1, x2, y2. So they took 9 minus 6 divided by 7 minus 5. And that gave us 3 halves. Okay. So if we look at the second example, again, I'm going to label these x1, y1, x2, y2. So in this case, we have negative 8 minus 10 divided by 1 minus negative 3. Remember, when you subtract a negative, it's the same as adding the positive. So this becomes negative 10 divided by 4. 10 and 4 have a common factor of 2, so this reduces to negative 5 halves. And I'll leave this last one to try. Okay. So the next thing we're going to look at is parallel lines. And if we have a set of parallel lines, they have the same slope. So if I'm given an equation of the line in slope-intercept form, y equals mx plus b, where m is 2 and b is the y-intercept, notice that my slope is 2. So to find the slope of the line parallel to this one, we need to write this in slope-intercept form. That means I'm going to have to subtract 4x from both sides, and I end up with y equals negative 4x plus 2. So if I'm looking for the slope of a line that's parallel to this one, that slope is going to be negative 4. We're going to step it up a little bit with this example. Notice that both of these lines are in standard form, and we need to rewrite them so that they're in slope-intercept form. So the first thing I'm going to do here is subtract 2x from both sides. I now have negative 3y equals negative 2x plus 6. And notice that I write the x term in front of the constant. Now I need y to have a coefficient of 1, so I'm going to divide everything by negative 3. And this will give me y equals, I have a negative divided by a negative, so that's going to make it positive 2/3 x, a positive divided by a negative minus 2. So if I want to find the equation of the line that is parallel to this line, the slope has to be 2/3. Okay? So it says write an equation of a line that is parallel to each one of these. Here's a hint. They're all going to have the same slope, but different y-intercepts. So if I look at this first one, I know that the slope has to be 2. So y equals 2x minus 5. That would be a parallel line. For the second one, y equals negative 4x plus 6. And for my last one, y equals 2/3 x plus 4. Let's just make it 4. So what I want you to notice is that they have the same slopes, but their y-intercepts are different. 2, 6, minus 2, plus 4. So those are parallel lines. Now, when we talk about perpendicular lines, they have the opposite signed reciprocal as the given line. Okay, so let's talk about opposite sign reciprocals. If my initial line has a slope of 5, the perpendicular slope is going to be the opposite sign reciprocal. Sometimes it helps to look at this as 5/1 because remember the reciprocal, you're simply flipping the fraction over. So what was your denominator is now your numerator. What was your numerator is now your denominator. And changing the sign. So here, if I have a slope of 3/2, the line perpendicular to that will have a slope of negative 2/3. If I have a slope of negative 10, again, if it helps, think of it as negative 10/1. The slope that is perpendicular to it, we're going to take the opposite sign. Since this is negative, it's going to be positive. We're going to take the reciprocal. So it would be 1/10. Here, I have a slope of negative 1/4. So since it's negative, that means this perpendicular slope is going to be positive. And the reciprocal of 1/4, you could write it as 4/1 or 4. So let's go through these lines and find the perpendicular slope, or the slope of the line that's perpendicular to it. This has a slope of 2. Again, if it makes sense, look at it as 2/1. We're going to take the reciprocal, which is 1/2, and the opposite sign. So this is negative 1/2. If I write this in slope-intercept form, notice my slope is negative 4. So the opposite of that is going to be positive, and the reciprocal of 4 is simply 1/4. Again, we need to write this in slope-intercept form. Get y equals 2/3 x minus 2. Since the slope is 2/3 and it's positive, my perpendicular slope is going to be negative, and the reciprocal is 3/2. So if I want to write lines that are perpendicular, the thing that's going to change is my slope. My y-intercepts can stay the same. So for this first one, if I want to write the equation of the line that's perpendicular, it would be y equals negative 1/2 x plus 5. For the second one, y equals 1/4 x. And I'm not even going to put a y-intercept. It's understood to go through the origin. And for this last one, y equals negative 3/2 x minus 2.